Welcome back. In this lecture, we shall explore encoders with a specific focus on the BERT models. So here are our lesson objectives. So earlier we described what's called the self-attention head, which is shown here, and this is the key neural unit that is used in what's called the transformer architecture. So as you may recall, we take the input and it goes three different ways into keys, values, and queries. The keys and values are assembled using attention weighting, and then the query is then compared to that to give you the output. Now this itself becomes a basic building block of what we call the encoder architecture that I'll describe next. So the encoder architecture is primarily used for things like assigning a label to textual data, sentiment analysis, a lot of the typical, what we would call earlier, a many-to-one task that you would see in other language models like an RNN. Now, this involves encoding textual input into the neural architecture to produce the output, and we'll describe how that's done in a moment. So at the base level, we have the input. So these are your words. Now, if you recall, when we talked about transformers, words not only have an embedding, but positional information is included in that embedding. And by doing this, by including the positional information in the embedding, remember, this is what allows us to parallelize things because we don't have this kind of series of neural units, one feeding into the other, that you have with an RNN. So that positional information is then combined with the initial input to give you positional embeddings. Now notice each of these embeddings, we have three arrows coming from it because we're going into the three different parts of the transformer architecture, which we see here, and that's the next layer in an encoder. Now the output of the transformer is then pushed through a dense layer. And then there's some normalization, some other things that are occurring on top of this prior to the output. Now typically all this together, with the exception of the embeddings, get stacked on top of one another, and we can have multiple encoder units. So the combination of the attention head and these dense layers with the normalization on top, those things together comprise an encoder, and you can stack multiple of those on top of each other, and that's what's often done. So the BERT model is a very popular pre-trained encoder transformer model. It was created by Google, but it is available open source. And it's pre-trained on two tasks. It's trained on what's called masked word prediction, where you have an input sentence and about 15% of that input is masked. And then what it's predicting is the missing words. The other thing is what's called next sentence prediction. That's actually taking two sentences as input and concluding if they belong to the same context. Now, this type of pre-training on these two tasks uses something called self-supervised learning, which allows the model to be trained on a lot of data, but not relying on a lot of labeling. And we'll touch on self-supervised training in a bit. Now, what happens is you have all this stuff that's pre-trained, and this is somewhere in the neighborhood of like 100 million parameters or so. So it's a big model, but it's small enough where you can still download it and use it yourself. Now, what you want to do is you want to do what's called fine-tuning, which is adapting this model for other tasks by doing things like integrating it in a larger architecture, adding additional layers, and so forth, usually a bunch of dense layers on top of that for a specific classification test. And the BERT models and its later variants have shown to be very effective when used in this way. Now let's talk a little bit about the self-supervised training. So when we have these neural models, they can get very large. And the larger the model you have, the more data you need to learn the weights within the model. Now, if you can't, unfortunately, you can't just arbitrarily grab more and more data, because in the supervised case, we, as you know from earlier lectures, expect labels with all of those samples. But when you start getting into very large amounts of data, internet scale data, labeling no longer becomes practical. So we have to think of something else. So this idea of self-supervised learning is saying, hey, we got this textual data. If we mask part of it, or if we arrange it in a certain way, we can draw conclusions from that without relying on labeling. So this idea of masking, which is one of the things done with the BERT model, is you might have something like this sentence: in the morning, I brush and floss my teeth. And then maybe the word teeth gets masked out. And so based on the beginning part of that sentence, what is that final word? And as you see right there, we can all guess as humans that with that particular sentence, if you hear in the morning I brush and floss my blank, most of us are going to likely fill in teeth with a very high probability. Essentially, we're getting the model to do the same thing. BERT has been very successfully deployed for many years now. One of the main applications has been improvements in Google search. Google has said that this was one of the biggest leaps forward in the history of search at the time of its release in 2018-2019 timeframe. It's open source and free to download, so if you're interested, the Google version for TensorFlow is available. Google is also the company that makes TensorFlow. However, there are PyTorch variants, and Meta is the company that makes PyTorch. You can get the PyTorch version also for free in a package called PyTorch Transformer. It's a relatively small model compared to some of the more recent large models we've seen, like the GPT series things that have billions of parameters. Here we're dealing with a 336 million parameter for what's called the large BERT model at the time of this recording. And so as a result, you can fine tune on commodity GPU hardware. So that wraps it up for encoders. Hope you enjoyed the lesson. This is a very exciting area, and a lot of good results have been gotten out of this, and we think it'll benefit you in your work. Thank you.